Hi, I'm Dries, the President and CEO of United Silicon Carbide. Normally, at this time of the year, I'd be traveling around the globe following up with customers that we would have met at various conferences such as APEC or PCIM earlier in the year. Of course, this year is different, so I thought I would take the opportunity to highlight for our partners around the world everything that has been happening at UnitedSiC over the course of the last year and provide a preview of the awesome new platform we will be releasing later this summer. Anyone involved in the power conversion industry can't miss the buzz surrounding wide bandgap devices and silicon carbide in particular. All of us in the industry are enjoying unprecedented growth in end markets such as vehicle electrification, IT infrastructure, and renewables. The success of silicon carbide has propelled the entire supply chain from substrate and epitaxial wafer suppliers to foundries and packaging partners to increase capacity to meet this growing demand. At UnitedSiC, our early foray into providing silicon carbide devices into the 650 volt market, along with our standard silicon gate drive, is propelling the replacement of traditional silicon superjunction MOSFETs with UnitedSiC FETs. The overall silicon carbide market is growing much more rapidly than the traditional silicon market as we take additional share. Our engineering and operations teams have been on a tear over the last year, introducing more than a dozen new FET designs addressing our end markets of automotive, battery charging, IT infrastructure, renewables, and circuit protection. All of these new products span a host of applications ranging from the world's lowest RDS(on) silicon carbide devices for automotive inverters to a series of JFETs for consumer flyback adapters to devices designed for high-power computer server applications. All of this technology was acknowledged in a key partnership that we announced with Analog Devices last year, who made a strategic investment in our business as we continue to grow faster than the overall market. In the automotive inverter space, we have numerous designs utilizing our sub-10 milliohm die at both 650 volts and 1200 volts. This application is conduction loss dominated, and here we deliver 3 to 7x lower losses than IGBTs while doubling their switching frequency. Owing to UnitedSiC's unique die size advantage, in any given inverter volume, UnitedSiC now delivers the customer's choice of either the highest output power or lowest loss silicon carbide inverter solution in the industry. As an example, the team at AC Propulsion and Beijing E-Motor allowed us to share the awesome performance they are getting from their discrete-based motor drive inverter. The 200 kilowatt design was built using 24 of UnitedSiC's 9 milliohm 1200 volt FETs in an extremely compact unit. They obtained efficiencies as high as 99% on these devices. In this work from home environment, our business in the data center area has been very robust. Many new designs are taking advantage of the performance of our Gen 4 technology, where we are enabling totem pole PFC efficiencies exceeding 99%. During my last trip to China prior to the pandemic, I encountered a new customer's design where they were replacing a traditional Vienna rectifier topology with a 6-switch implementation with our 40 milliohm 1200 volt FETs. They achieved higher efficiency and shared with us that the overall bill of materials cost was actually cheaper than the legacy silicon design they had. As we continue to innovate our silicon carbide FETs, I expect to see this more and more, where we were able to replace silicon at the same or better overall cost at higher efficiency. A huge part of our business over the last several years has been in EV charging, not just onboard chargers, but in fast DC chargers up to 350 kilowatts as well. Many of the Electrify America fast DC chargers across the US incorporate charging piles with many of our 1200 volt FETs in parallel. Another company in Europe won a Best of CES award this January by designing in our 7 milliohm 650 volt FETs into their very innovative off-board bidirectional charger. This enables energy stored in a vehicle's battery to flow back to the grid or power appliances within a home. Another area where we're displacing silicon is in applications that require surface mount packages. Our die size advantage is so great over competitive technologies, we're able to use just 4 devices where the competition requires 6 in an LLC application. We achieve this while maintaining between 33 and 35% lower losses. This enables many designers to achieve power densities not previously achievable. While all of this activity has been incredibly exciting here in the first half of 2020, we are just getting started. I'll preview in the next couple of slides our next generation FET technology, which releases in the second half of this year. We're already working these FETs into designs at customers right now. Comparing our Gen 4 technology to our Gen 3, we have improved it in nearly every way. First, we have increased our blocking voltage from 650 volts to 750 volts to provide additional headroom for higher bus voltage automotive designs. We nearly halved our QRR, and total switching losses are reduced by 33%. These devices are extremely robust and are perfect for traction inverter drives where we achieve an 8 microsecond short circuit rating and doubled our body diode surge rating. The team is working very hard on the derivative portfolio of these devices across voltage nodes, package types, and RDS(on) values. You will be sure to find a device appropriate for your end application. Comparing our devices to the latest and greatest of our competitors' offerings is even more illustrative. Compared to the most widely deployed silicon carbide FET in the industry right now, our Gen 4 devices provide up to 1/4 the RDS(on) at only 12% larger die area. This enables power modules that operate at significantly lower losses and dramatically higher power densities than our nearest silicon carbide or silicon IGBT competitors. I have to tell you that I'm personally excited to buy a vehicle in the coming years with a UnitedSiC derived inverter. Many thanks for taking the time to watch this presentation on behalf of the entire team at UnitedSiC. We're thrilled to be on this wide bandgap odyssey with our partners throughout the power electronics industry. We wish you and your families the best of health, and please stay safe. Thanks.